So 6-5 quiz, here we go. I'll tell you the answers. I'm going to say some side stuff. You don't have to write down any of the side stuff because once we're done grading this, I'll give you another study guide for the next quiz up. But some of the stuff I say will become the questions. So listening is your friend, but furiously writing down what I'm saying is not necessary. One is a thing called covalent bonds. So key word on covalent bonds when we move forward is going to be the word sharing of electrons. Some factoids on this that may or may not make the next quiz. We no longer have a thing called formula units, which are a description of bonding whenever we have the electrons being gained and lost. But we now have a thing called molecules, and molecules is an old word for us. So molecules are formed from covalent bonds. Formula units were formed from ionic bonds. These usually have lower melting points once you do this kind of bonding, but they don't conduct electricity like the other kind of bond tend to do. In terms of trying to explain what's happening, I'm going to go back to our dots. There are dots in our past, and there are a lot more dots in our future. So if I start talking about a hydrogen bumping into another hydrogen, what do the dots represent when we did dots before? The valence electrons. How many dots were on hydrogen? One. So this hydrogen has one, and the hydrogen on the right has one. And if they come together, all of a sudden, it looks like they have two. This one feels like it has two, and this one feels like it has two, and you're fine because they're sharing, and that's why the word of the day was sharing for covalent bond. Chlorine meeting up with another chlorine would also do that same kind of bond. Just chlorine has, somebody with a table handy? It does have 7 because it's in column 7. And really what I should do here, and this will happen in days marching forward, if we do like one kind of dot for one, we should do some other kind of dot for another. So I'll break out my colors because that's an easy way to do this. So we have a white hydrogen, we've got a green hydrogen, and it looks like now they had 2. Chlorine, we'd have 7 white ones from the one chlorine, but then you'd end up with 7 green ones from the other chlorine, and it looks like they both have 8, just a mix of whites and greens. We could also do this with hydrogen bumping into chlorine, because as we said, chlorine has 7, everybody wants to have 8, so chlorine comes in with its 7 like this, and then it can grab that 8th one from hydrogen. And hydrogen's happy because it bumped up to 2, and chlorine's happy because it bumped up to 8. That's the idea of covalent bonding. We're going to share electrons, not transfer them, but share them. Question about concept? Okay. So back to grading. In the order that they did them of the book, sentences that you had to choose from are that the properties of the individual atoms are different from the molecule, or that the new molecule is more stable, or unlikely that you said the orbitals overlap as much as possible without repelling, because that's a longer sentence, but if you said that, that's fine. That has something to do with bond lengths, and that fact is not going to make future quizzes, so that one's not equal in importance to the other ones. Energy is given off when forming bonds is another sentence you could have used, which makes sense. I think we would understand it better on the flip side maybe. To break a bond is going to take some energy. You're not just going to do that. It's going to take some energy to break a bond. So the reverse has to be true. To make a bond, energy has to be given off. 4 is diatomic molecules. Everything that I just did behind me is a diatomic molecule because all of the diagrams that I did had 2 atoms to make a molecule. That isn't the way it always has to go. 5 is bond length. That one's just kind of like self-explanatory. The distance of things that are bonded is called their bond length. Electronegativity is an important word of the day. So, anybody pick up on the higher numbers? What does that mean about electrons? It wants them more. So I'm going to give you a periodic table that was copied out of the book that has the electronegativities. The highest numbers mean highest want for electrons. It's measuring how much electrons are desired by these elements. The rankings will go from 4.0 at the highest, like your GPA, as low as a 0.7 is the lowest number that goes on this table. 7 is Coulomb's law. Basic short form of this is smaller atoms attract each other more. Is the name of that game. Polar bond is the last one that we were filling in, and I'll have a brief discussion once I give you your table about polar bonds and the homework and what something looks like, but we can't quite do that yet. Question about first 8. Then it's oldies. 9 is attractive force that holds atom together. 10 is ionic versus covalent. Those will still live on. 12 to 19 are gone for the next quiz, so it's the last time you'll see these till the test. 12 is valence electrons. 8, helium, lose, gain, share. 18 is energy to remove electron. 19 is energy given when we have an atom gain an electron. 20 is an anion, and then cation for the second blank, and these questions do live on. 22, Roman numerals half, left being positive, right being negative is the other half. 0, 0, twice in a row 0, then ionic charge finishes the front. Question front. Before I keep going, did anybody not realize there was a back? Every once in a while that happens. Okay. So 26 is the sum of the oxidation numbers of the atoms. 27 is positive. 28 is electronegative. 29 is positive 1, and then negative 2. On the oxidation numbers, the sign is supposed to go first, but I'm not going to mark anything wrong over that, not even halves. 31 is a force of attraction between ions of opposite charge that holds them together. That might be a half point kind of thing because there's a lot of words there. Force of attraction, ions of opposite charge, holds them together. 32 is electron transfers. 33 is properties. 33 is the protons and the electrons. Probably should say in the ion, but I'm not going to hassle anybody over that today. 35 is radius, radii if you like a fancy plural word with a double I. 36 is energy. 37 is called formula units. Today, again, formula units went out, and who came in? What's it called now? Not formula units. Molecules are in. 38 is a no. 39 is high melting points. And if you just say conduct electricity, I'll give it. But the full thing should be conduct electricity if they're liquids or if they're in a solution. Question up to 40. So let me give you the promised periodic table that I said, and the study guide paper that I said. So let's start with the periodic table, brief discussion. It's just a partial table, it's not the full table, it's just a partial table of elements that commonly do go try to get involved with compounds. What did the higher numbers on this mean?
They're more, they want to combine more,
They want something.
They want electrons.
They want electrons. So the highest number wants electrons. So who is the champ of all champs of wanting electrons the most? Fluorine. With a 4.0, that's our highest number. Who's in second place of wanting electrons the second most? Oxygen. Third place is a tie.
Nitrogen and chlorine.
Nitrogen and chlorine. fourth place is not a tie.
2.8, right?
Bromine. Then there's another tie for fifth place.
Iodine, sulfur.
Iodine, sulfur, and
Carbon.
carbon. Someday, if you want to make me this little diagram of a cheat sheet, and you could use this on your homework, it might help you here or there. This is like the top 10-ish in order. So this would be an extra point diagram, not a quiz needed diagram, but fluorine's in first place, oxygen's in second place, chlorine ties with nitrogen, bromine is next, iodine, carbon, and sulfur is a three-way tie, phosphorus and hydrogen are in a tie. Those are the most often one used you'll see in the homework. So here's what the homework tonight's going to ask you to do, and this is pretty easy. This is about as easy as a homework probably can get. We're looking to work 10 and 11 is mainly what I'm about to do, as well as some scattered specs of other things. Yeah, 11's what I'm about to do. 10 is a different question unrelated to what I'm about to do, but I'll tell you the answer to that in a second. What they're going to do is give you like a molecule. HCl is a molecule. And we're going to look at this electronegativity, or just look at the little cheat sheet. Who wants electrons more, chlorine or hydrogen? Chlorine, because it's higher on my cheat sheet. Or if I look at this, it has the higher number. Chlorine wants electrons more than hydrogen does. So even though they're not transferring electrons, chlorine wanting electrons more, it's kind of like giving you the vibe that it's just going to take it because it's a bully, because it has the higher number. So if it's taking the electron, what kind of charge does it have? Negative. So they're going to have you draw this Greek letter that I forget what letter that even is. Maybe that's lambda. I don't remember. It's what? Lowercase delta. Good call. Thank you. So it looks kind of like an incomplete 8. It's like close to an 8, but not quite an 8 looking thing. We're going to draw that symbol and put a minus to label that chlorine wanted the electron more. And therefore the hydrogen, we do that symbol, but give it a plus. So what they're going to have you do in number 11 is just label which one wanted the electron more with a minus and which one didn't want it as much with a plus. And you could probably use this for most of it, but if it's not in this, just grab the table and grab its number. But again, moral of the story, higher number, what's the deal? Wants them the most. So give that the minus sign. Question about that game?
Yeah, are we gonna have that on a test or a quiz? Or
Yeah, well, I don't know. I'll describe the next quiz off the study sheet I gave you in a second, but I'm sure the test will have a question, like the problem test would have you do that on a problem test. And I would have to give you these. No one is expected to memorize any of these electronegativities. Okay, but I'd give you this, and that's how you could make your judgment. You with that? Okay. So total on that homework, 10, 11 is the main problems, but there's a 2E, a 2B, a 1 L through Q that's vocab based, but the main thing is that 10 is a single question, 11 does the thing where they go A, B, C, D, E, F, G, H, I, J. Question about use of the table. Then let's look at quiz. So 6-6 preview is in front of you. You can see there's 2 new questions. They're both going to be obvious and they'll both be fill-ins. So 6-6 is not a heavy read at all. Compared to today's, I kept number 9. You can see that as number 3. I kept 10, sort of, but it became name and define. So ionic, what's the key on ionic? We're transfer electrons. And then the new one, covalent, shares electrons. So 4 to 7 is presented in a new way, but those aren't new facts. Then skip down to 20. From 20 to the bottom, it looks just like keeper, keeper, keepers. I don't see any changes for a while there. Those look like all winners. And then we need to kick in on 27. is where the new stuff from today changes form. So today, Polar Bond made the list. A thought on what a polar molecule was about?
Molecules with opposite charges.
It's partly sort of there. Grab it off of the quiz, it's there. Unequal sharing of electrons. This would be an example of that, because chlorine wanted electrons more. Hydrogen, not so much. That's unequal sharing. Even though they did share one apiece, it's not equal sharing in count. It's equal sharing, like, did it really matter to them? Chlorine wanted it more than hydrogen did. So that's unequal sharing of the electrons because they had different electronegativities. That would be an example of a polar molecule. So what would you guess nonpolar molecules are about then? Equal sharing of electrons. That's what we saw here. Hydrogen shared with hydrogen in the first thing I drew you. That's equal sharing. Chlorine shared with chlorine. That's equal sharing. Could you have equal sharing if they weren't the same? Yeah. Because, like, who could have done that for us? Yeah, like chlorine and nitrogen or something. You could have equal sharing even if they're different. But if they're the same as each other, clearly that's equal sharing. If they're different from each other, it's probably unequal sharing, but who knows? Diatomic molecule goes in reverse of what we said. What's a diatomic molecule? It has 2 atoms. And then I'm going to ask you to list 7 of them. So we already have 2 on the board. One natural diatomic molecule is hydrogen, because hydrogen has 1 electron, wants to have 2. Plain old hydrogen as a single H floating around isn't going to last long. It's going to find itself another H and latch on hard. H can't be found in nature as H. It's always going to be H2. What's the other one that is already up here? Chlorine. So chlorine's another one. So H, Cl. Use your periodic table. If Cl is in the club, who else do you think is in this club? Fluorine, yes, F. Oxygen is a different column, but still yes. Oxygen has 6. Oxygen will try to get with other oxygens. But sticking with our table, if we've got Cl and F in the list. Bromine, absolutely. Iodine, absolutely. Why are we picking those out? They're in column 7. What's column 7 called? Old word. Halogens. Grab all those halogens. So there's 4 of them from halogens. Hydrogen makes 5. Oxygen we locked our way into is 6. Nitrogen's the other one. So when I do my list, I started off with I, O, and N because it spells ion, and I find that easy to remember because that's a chemistry word. So I always put I, O, N, H because I can't forget H, and then I just try to do my halogens with F, Cl, and Br. I don't care what order you put them in, but if you want to go I, O, N first, that's 3 nice words that spell a word, and H is just always wants to play with us. But I, O, N, H, F, Cl, Br, that's our 7 that have to be diatomic. There is no such thing in nature as O. It's going to always pair up and be another O to make an O2. 31. What were our number range from who to who? 0.7 up to 4.0 or 4. I don't care if you put 4.0 or 4. That's up to you. And then here I asked it in a different way than I have been all period. What do low numbers mean? They don't care about electrons. Don't have an attraction to electrons. If I switch it up and ask you high some other day, high numbers mean they have a high attraction to electrons or a strong attraction to electrons. The 0.7 end of things, they don't have an attraction to electrons. 33, I don't know if I said when I was saying, yeah, I did say that. This is an offshoot of Coulomb's law. But a thought on 33? Smaller atoms have greater attraction. 34, 35 is this idea of these two symbols. So the first blank is the delta symbol with a minus, and then the second one therefore must be the delta symbol, the plus. And that's pretty much a wrap. The other stuff in there, while true, it just doesn't get promoted up to quiz level answer. Question about 6.6 study guide and or making sense out of what 6.5 reading was trying to talk to you about. Anybody anything about any of that? Anybody have old homework issues if you've tried to get back there? Has anybody gotten stuck on anything from like the 9876 stuff? Then here's your promised fact to do the one other homework question. However much energy it takes to break a bond would be the same amount of energy given off when you create a bond. So whatever energy is happening in the one direction, it's the same amount of energy happening in the other direction. That's what homework question 10 is about. They're going to tell you how many joules it takes to either do it or undo it. It's just the same amount of joules to kick it into reverse. So 10 is that, 11 is this plus minus game, and the other homework is just vocab specs. Anybody, anything I can do for you before we close up shop? Okay, so you can shut that down. Thank you, cameraman.